Hello everyone. In this video, we will learn to predict if a precipitate occurs or not when two soluble salt solutions are mixed with each other.
In my earlier videos, we have seen the equilibrium reaction between solid silver chloride and Ag plus and Cl minus ions. The Ksp value for this reaction is 1.96 times 10 to the negative 10. Since this is an equilibrium reaction, I can start this reaction either from the reactant side or from the product side. That is, I can add solid silver chloride to water and let it dissociate to form Ag plus and Cl minus ions, or I can mix Ag plus and Cl minus ions and let them combine to form AgCl precipitate. Let us say I start the reaction with the reactants, that is, I add solid silver chloride to some water in a beaker and let it dissociate to form Ag plus and Cl minus ions. In chemical equilibrium chapter, we learned how to calculate the value of the reaction quotient Q. For this reaction, Q is equal to concentration of Ag plus times concentration of Cl minus. Now the Q is different than that of the equilibrium constant in that the concentrations in this equation could be any concentrations, not necessarily the concentrations at equilibrium. If we start only with the reactants, then the Q value is 0. In the same chemical equilibrium chapter, we also learned that if Q is less than K, the reaction proceeds to the right until the Q value becomes equal to the K value. That is, the product of concentrations of Ag plus times Cl minus is equal to Ksp, which is equal to 1.96 times 10 to the negative 10. Therefore, the AgCl precipitate slowly dissolves to produce Ag plus and Cl minus ions until the product of the concentrations of Ag plus and Cl minus is equal to 1.96 times 10 to the negative 10. If we have more AgCl, then it stays as solid precipitate at the bottom of the solution. What if we run out of all the AgCl before the product of the concentration of Ag plus and Cl minus reaches the Ksp value? In that case, all the AgCl is soluble in water and forms an unsaturated solution without a solid precipitate at the bottom of the solution. It is important to understand that the Ksp is the maximum amount of Ag plus and Cl minus ions that can coexist in the solution without precipitating. In the next slide, we will see what happens if we start the reaction from the product side. Let us say I start the reaction from the product side. That is, I mix Ag plus ion and Cl minus ion and let them combine to form AgCl precipitate. I can achieve this by mixing sodium chloride solution, which is a soluble salt, therefore essentially Na plus and Cl minus ions, with AgNO3 solution, again a soluble salt, therefore it is essentially Ag plus and NO3 minus ions. When you mix these two solutions, we have all four ions in the same beaker. The attraction between the Ag plus and Cl minus ion is greater than the attraction between the individual ions and the water molecules. Therefore, Ag plus and Cl minus ions combine to form AgCl precipitate. These kinds of reactions are called precipitation reactions. For a precipitation reaction to occur, there should be a sufficient amount of ions present in the solution. In order to predict if the precipitate forms or not, we need to calculate the reaction quotient Q. Q is equal to Ag plus concentration times Cl minus concentration, where Ag plus and Cl minus are initial concentrations, that is, before any reaction takes place. If the Q value is less than the Ksp, that means we do not have the maximum amount of ions that can coexist in the solution. Therefore, no precipitation occurs. If the Q value is equal to Ksp, then we have exactly the maximum amount of ions that can coexist in the solution. Therefore, the precipitation reaction begins at that stage. In the third case, if Qsp is greater than Ksp, then we have more than maximum amount of ions that can coexist in the solution. Therefore, a precipitate will be formed in this stage. In the next slide, we will try to apply this concept in solving a problem. In this slide, we will predict if a precipitate occurs or not when we mix 100 ml of 1 millimolar silver nitrate with 100 ml of 1 millimolar sodium chloride. We need to calculate the Q value and compare it with the Ksp value to be able to predict if the precipitation occurs or not. The reaction quotient Q is equal to Ag plus concentration times Cl minus concentration, where the concentrations are initial concentrations, that is, after mixing both the solutions, but before any reaction started between Ag plus and Cl minus. So let us calculate the concentration of Ag plus after mixing. The initial volume is 100 ml, the initial concentration is 1 millimolar, and the final volume is 200 ml. If we plug in these values into the dilution formula, we get the final concentration after mixing is equal to 0.5 millimolar. Similarly, the concentration of Cl minus after mixing is also equal to 0.5 millimolar. The reaction quotient Q is equal to the concentration of Ag plus times Cl minus is equal to 0.5 millimolar times 0.5 millimolars. You end up getting 2.5 times 10 to the negative 5. We know that the maximum amount of Ag plus and Cl minus ions that can coexist in a solution without precipitation is equal to the Ksp value, that is 1.96 times 10 to the negative 10. The Q value that we calculated is much greater than the Ksp value. Therefore, the silver chloride will precipitate out of the solution.